Hello, this is video number 13. I'm going to go over how to add vectors using the graphical method. At the end of the video, I'll actually go over vector subtraction as well. So the method I like to use to add vectors is the tip-to-tail method. So when you're adding vectors, the sum of all of these vectors is called a resultant. So in this picture here, you can see we have 4 vectors that we're adding, vector A, B, C, and D. And in order to add them, then what we do is we put each vector at the tip of the previous one. That's what we did with B, C, and D. And then the resultant is drawn from the tail of the first vector, which is right here, to the tip of the last vector, which is right here. So the way to think about this is if you go this way along vector A and then along vector B and C and D, well, where did you end up? You ended up right here at the tip of D. Where did you start? Right here at the tail of A. So you ended up traveling this way, and this is what we call the resultant vector. So just a recap of how do we add vectors using the tip-to-tail method. This picture just has 2 vectors that we're adding. You draw the first vector, you place the second vector at the tip of the first one, and then you draw an arrow from the tail of the first one to the tip of the second one. So I just like to think of you draw an arrow from where you started to where you ended. That will be the resultant vector. Let's do an example using the tip-to-tail method. You're on a treasure hunt and your map says walk due east for 45 paces, walk at an angle 30 degrees north of west for 60 paces, and finally walk due north for 25 paces. Determine the resultant displacement using the tip-to-tail method. So we need to draw these vectors. So let's draw the first vector to the east. Now, I don't have a ruler and a protractor, so I'm not going to be exact. But in order to be as accurate as I can, what I'm going to do is I'm going to draw some tick marks. So each tick mark will be about 10 paces. So let's see here. Draw my line. So 1, 2, 3, 4.5. That's going to be 4.5 paces. That's going to be 45 paces. Each of these is 10. And I'm going to call this vector A. Now at the tip of vector A, I draw the second vector, which is 30 degrees north of west. So we talked about this in a previous video. How do we interpret north of west? We draw the second thing first. That means going to the west here. We draw that first. And then I'm going to draw it with an imaginary line here. We're drawing a line to the left here. And then we want to go north of that 30 degrees. So we want to go this way. And again, this looks a little bit too big here. This is not perfect since I don't have a protractor. But this should be approximately 30 degrees north of the west direction, which was to the right here. And since I need 60 paces, I'll do 6 tick marks. 1, 2, 3, 4, 5, 6. Again, this is not perfect. If you have a rule and a protractor, you can definitely be more exact. And I'll call this vector B. It's always useful to label our vectors. And finally, we're going to walk north for 25 paces. So I'm going to go straight up. 1, 2, 2.5 tick marks. Again, I'm trying to be as exact as I can. It doesn't have to be perfect. I'll call this vector C. Now the tip-to-tail method says that we're going to draw a resultant vector from where we started, from tail of A, to where we ended the tip of C. So a straight line here. That is my resultant. So as far as the tip-to-tail method is concerned, well, what can we say about the resultant? Well, if we had a ruler, we could approximate the length of this and compare it to the length of 10 paces and figure out how many paces it is. And if we had a protractor, we could measure this angle here. I'm just going to approximate, trying to use the same distance here for each of my 10 paces. 1, 2, right? Each of these are 10 paces. 1, 2, 3, 4, 5. I'll say I have about 5.5 tick marks, which is approximately 55 paces. This is just an approximation. And then the angle, well, it looks like it's more than 90 degrees. So, because 90 degrees would be this angle here. So I'll say it's about 100 degrees, my direction. and I'm using a positive angle, meaning counterclockwise, I could also say, well, if I start at the north, then I'm going 10 degrees to the west, so 10 degrees west of north. Now this is just an approximation. The tip-to-tail method does not give us exact answers if we're not very exact with our drawing, but it's a good start so we have an idea of what the answer is supposed to be. And in a different video coming up soon, we'll learn about how to use the analytical method to add vectors to get more exact answers. The last thing I'd like to go over, I have your turn first. So which one of these in the diagram is the resultant? So you want to think about which vectors that you're putting tip to tail, and then which one you're starting from the tail of the first one and ending up at the tip of the second one. So it turns out that vector A is actually the resultant, because if you start at vector B right here, then you put vector C here, the tip of vector B, then we started here and we ended here. And that's exactly what vector A is showing. That means that A is actually equal to B plus C. And the last thing I'd like to go over is vector subtraction. I have it in this video because vector subtraction really is the same thing as vector addition. The only difference is that instead of adding two vectors, you're going to add the negative of the second vector, because you know that A minus B is the same as A plus negative B. So the trick is to use what we learned about what a negative vector means. A negative vector means it's the same vector but in the opposite direction. So in this picture here, vector B, the original vector B, was going this way. So that means that vector negative B is going in the opposite direction. So if we're trying to do A minus B, we're going to add vector A plus vector negative B, and that's what's shown in this diagram. We start with vector A, and then we place the tip of negative B here, the tail of negative B at the tip of vector A, right here, going down here. We started here, and we ended up here, and that's what vector A minus B is showing. We can call this the resultant as well. So vector subtraction is just like vector addition. Just make sure to redraw the vector first in the opposite direction, and then you're ready to add the two vectors. So to finish off, I have one more your turn here. So vector A points due east and vector B points due south. Both vectors have the same magnitude. In what direction will the resultant A minus B points? So what you want to do is you want to draw these. Vector A is east, vector B is south. But since you're subtracting them, make sure that you draw vector negative B, which will be north. And now you're ready to add A plus a negative B. So you're going to draw A. At the tip of A, you're going to draw negative B. And then you're going to draw a vector from the tail of A to the tip of negative B, from where you started to where you ended. That's your resultant, which is not called B, it's called R. And which direction is this? Well, this is north of east, because you draw the east, and you have to go north of that. So the answer is actually vector C. So this is the end of this video. We went over the tip-to-tail method. Just draw vectors one at a time. Always start the second vector where you ended the first vector, and draw that resultant vector from where you started to the very end where you stopped. That will give you a resultant. But remember, if you need an exact answer, you're going to want to use the analytical method, which we're going to go over in a few more videos.